Okay, so here we are on College Board's website, and we're looking at specifically the AP Calculus exam. This is the BC exam, but the format for the AB exam is exactly the same. So let me scroll down just a little bit so we can see what the format looks like. So essentially there's two sections. You got a multiple choice section and you got a free response section, which is pretty common for AP exams. And our multiple choice section, it actually has two parts. So the first part, Part A, 30 questions, 60 minutes. It's about 2 minutes per question on average, where you don't get to use your calculator. However, on the second part, 15 questions, over 45 minutes, an average of 3 minutes per question, you do get to use your graphing calculator, okay? And these are 4 answer choice, multiple choice type questions. Okay, on the second one, free response section, open-ended kind of questions, and it has 6. Both AB and BC have 6 over the course of an hour and a half, where it's broken up into 2 parts. The first part, the first 2 questions on part A, you do get to use your calculator, and it's 30 minutes. So that averages about 15 minutes apiece for each free response question, and that will hold true throughout the rest of this year. We want to kind of try to average or aim for about 15 minutes on each one of those free response questions. The second part, 4 questions, 60 minutes, and you do not get to use your calculator. So you have your calculator out for the first 2, and then they have you put it away for the last 4. Now, as far as these 6 questions go, 3 of them on the BC exam are identical to 3 of the questions on the AB exam, which is what in part allows them to give you an AB subscore. You get a BC score out of 5, and you also get a subscore, what you would have gotten on the AB exam if you had taken it. So it's possible that you don't get credit for BC, even though you took the BC exam, but you still get credit for the AB part of it. All right, let me tie this into the current objective, which was about average rate of change, using that in order to approximate the instantaneous rate of change. Here are the questions, the free response questions for BC Calculus in 2018. And like I said, some of these questions, 3 of them were identical to the ones on the AB exam. So this is kind of the format. This is what they will look like. So sometimes you will have yourself a question stem with an equation in it, and then you usually have 3 or 4 parts that are tied to it. This one's a calculator question, and likewise, so is the next one. So this one is just a contextual problems, just all word problems, but each of those 4 parts are tied into that word problem right there on number 2. Okay, it's pretty common that we have, say, a picture of a graph that we're having to do calculus with a question stem and 4 parts to it, or maybe even a table of values like we see in number 4. And this is the one that I want to take a look at because, like I said, there's a direct relationship to what we just did in example 4. So let's take a look at it. We do have a table of values. We got T years, we have H of T meters. And on number 4, the height of a tree at time t is given by a twice differentiable function h. So don't worry about the fact that we don't know exactly what that means, twice differentiable. It just simply means you're allowed to take 2 derivatives. It's possible to take 2 derivatives of this, which, remember I said, is associated with slope, where h of t is measured in meters and t is measured in years. So this setup is pretty similar to the question that we were just looking at with a camera. Selected values of h of t are given in the table above. On part A, and this is the only part that we're concerned with here, is part A, use the data in the table to estimate, the way I read this is, h prime of 6. That is the first derivative of h at 6. Of course, we don't know what that means yet, but it's the same thing that we just found. We want the slope of the tangent line at t equals 6 years. That's what that fancy notation means. Using correct units, interpret the meaning of h prime of 6 in the context of the problem. So I wanted to show you this to kind of clue you in to the fact that we've already gotten enough calculus under our belt in order to accurately answer one of these, or at least a part of these free response questions. So I'm going to take a snapshot of this, and I'm going to pull this into Notability so that we can actually work out that portion of it. You'll see it's going to be easy right there. Insert. Okay, And I'll crop it a bit because we don't need that whole entire question. We just need up to part A. Go away. All right, there we go. Fantastic. Okay. So we're trying to find this thing, h prime of 6, which, as I said, is exactly what we found right up here. It's the slope of the tangent line, and then specifically at 6 years. And notice that there's no 6 in here. All right, so back here on this one, it had, I highlighted it in green, the point that we actually wanted to estimate the tangent line at, the instantaneous rate of change, and we still use the 2 that surrounded it for a secant line, the average rate of change. We're going to do something identical. So we're approximating, so I'm going to use the approximation signs, and I'm going to approximate this instantaneous rate of change, tangent line, with an average rate of change, a secant line. So I want to find the closest secant line to 6. So which numbers am I going to use in the table? I need to use in between 5 and 6. 5 and 7, because that's what surrounds t equals 6 years. So this problem, you're going to see, is basically like an algebra 1 kind of problem. I just want to find the slope. Change in y over change in x, which in this case is change in h over change in t. So let's just subtract 11 minus 6, and then keep it in the same order. 7 minus 5. Okay, and on our AP free response questions, there's this concept of a safe stop. A safe stop is you have done all of the calculus and all that's left is some simplification of arithmetic or something like that. And on parts of the question in which you don't get to use a calculator, we're allowed to do a safe stop so that we can avoid missing the question for arithmetic errors instead of calculus errors. So it's perfectly acceptable to leave it at this stage, 11 minus 6 over 7 minus 5 as a safe stop. You'd still have to do the rest of the question, like correct units, interpreting the meaning in the context of the problem, but as far as the number goes, that's okay. However, sometimes you need that number in another part, and so it's kind of cumbersome for us to just leave it as this unsimplified fraction. So let's just keep going. It's pretty easy. Anyway, 11 minus 6 gives us 5 on the top, and then 7 minus 5 gives us 2 on the bottom. Okay. Now, it does say we want some correct units. So we're going to do the same kind of analysis that we did on the previous question. So as far as the units goes here, the 5, which corresponded to the 11 and the 6, that's the stuff that's in the bottom. That's in meters. Okay, and then on the 2, which corresponds to the 7 minus 5, that's the stuff that's on the top. That corresponds with years. So there's our units. We just put it in order like this. Meters per year, right? It's just like a slope, except for like it's a distance over time. So it's just like kind of a rate in that sense. Now I do want, the next part of this is interpret. Oh, before I move on, if it does specify units, then you can bet that your score is tied to you putting the correct units on there. And that's usually one of the 9 points associated with a given free response question. All right, so I'm going to do exactly what I did up here. I want a time that it happens, I want a rate at which it happens, and then I want the units. So what is this anyway? This 5 over 2, this was supposed to be meters per year, but what's happening? What's happening in the context of this particular problem is that the height of the tree, it's increasing. It's getting bigger. It's growing at a rate of 2.5, 5 halves meters per year. But specifically, like we did up here, we want to highlight the fact that that is only valid at a particular time, a particular instant, an instantaneous rate of change. So at t equals 6 years, the height of the tree that's not tree, now it is increasing at a rate of approximately, because we did use a approximation with a secant line, 5/2 meters per year. And that has it covered. We had a time at which it happened, we had a rate at which it happened, and then we also have the units. So you can see how closely related that was to the camera question that we did directly before that. Okay, so in the next video, we're going to look at in more detail the differences between average and instantaneous rate of change.